Thank you. And I was so in my Zen moment. And now you bring all that emotion to me. Dear Minister, dear Mayor, dear Bart, dear friends of Bicardis, my dearest Bicardis colleagues, this is it. This is the moment. This is a moment that all of us have been waiting for so long. In fact, we are both at the same time at the end of a journey and at the beginning of a next journey. And like journeys goes of humanity, the path behind us was a many year path. Idylla, you already mentioned it. It started many years ago actually at Philips. And today we have in this room some of the pioneers who started that program. In 2009-10, I was so fortunate to meet counterparts there with vision, with creativity, and I think we came to a great solution. What you're going to see today, what we're going to launch here, is indeed, Bart, an example of creativity. Not just of innovation, but of disruptive innovation. Of a desire to go for the best, not make shortcuts, not be satisfied with average, but to really build something that the world has never seen before. But like human journeys go too, the real success is fought when you are down. And I can tell you, there have been numerous moments that we were with our knees, if not with our chin, into the mud. And each time we had to get up and move forward. So what is Idylla? And more importantly, before we're going to show it to you, let me show you a little bit about what the bigger context is. We're in medicine. In the last 100 years, we have seen over all the world an unprecedented improvement in healthcare, in health. Believe it or not, compared to 100 years ago, on a global scale, we live on average 25 years longer than 100 years ago. But we're not there yet. The Ebola outbreak just shows us right now that still many diseases are not really properly treated. There are many infectious diseases, and what we have is not optimal. Just in cancer, just one number, because more important behind the numbers are the faces of people we know. Every year, about 14 million people in the world, that's bigger than Belgium, get the bad news that they have cancer. In Belgium, more than 60,000, that's about half of the people in this room who every day get that bad news. So let me tell you that despite those realities, what makes medicine this moment so exciting? And it's personalized medicine. What is personalized medicine, which many of us in this room have been talking about? Medicine which many groups in Flanders, in Belgium, have been working on very much. We know that the drugs that, for instance, my great example, Dr. Paul Janssen and his team worked on so many years, they're great. But still, we see many situations where when you take a group of people who all seem to have the same symptoms, say cancer or colon cancer, that in reality, when we try to treat them, they don't always react in the same way. Maybe on those 165 respond. The others a little bit, and some of them not. So what is personalized medicine? Which is a bit of a weird name, I think many of us agree, because it suggests medicine was never personal. Of course it's personal. It hurts when you are sick. But personalized medicine is high precision medicine. And that's the excited. Centers like VIB and research centers all over the world have eluded the genetic code. They've started to understand that underneath what looks like a common set of symptoms, there are actually different subtypes of diseases. Some of the speakers, Philip, you're going to talk a little bit about liquid biopsies. The fact that some of these diseases have already little signs in our body days, weeks, if not years before the disease appears. So it's clear that that ideal of having one drug to treat them all is not really realistic. The future is that we use some measurements, some molecular measurements, to make sure that we're going to treat the right patients. And the reason for that we all may be equal, but at the molecular level, we're absolutely not identical. We're born with a specific set of genes, we live differently, we eat differently, and all those things are going to the deep blueprint of our bodies, of our cells, and unfortunately, in a number of cases, make that mistake that results into disease. So the future of medicine, and also very important for society, which I'll come to in a few moments, is not just try at random, try and error. No, it's the right therapy for the right patient at the right time and dose. And something we also added is at the right place. As medicine is changing, and as we're increasingly going to rely on making molecular measurements, it's absolutely essential that we do something about that magic interaction between a physician and a patient. When that patient is sick and is looking into the eyes of his physician and say, "What are you going to do with me? How am I going to get better?" So we made a little movie. What happens after a patient is seeing his doctor, an oncologist, and the oncologist asks the surgeon, "We've seen something on a scan, there's something seems to be wrong. Can you go and figure out whether it's cancer or not, what stage of the disease the cancer is, and what we can do about that patient?" So this is a small video.
Being diagnosed with cancer makes your world fall apart. And although you're confused and scared, action needs to be taken immediately. This is the start of a nerve-wracking time in which a series of tests are done in order to find the most beneficial therapy. A biopsy is sent to the pathology lab. Once the tissue arrives, the sample is registered. A laboratory technician cuts the tissue into smaller pieces and transfers them into a cassette. This incubates overnight in formalin. The next day, the tissue is embedded with fluid paraffin. The paraffin block is cut into thin slices, which are transferred into a warm water bath and captured on a glass slide to obtain nicely stretched tissue slices. After drying, the glass slides are transferred to an H&E stainer, where the tissue is stained for examination. Once the presence of cancer has been confirmed, the pathologist requests a PCR test. A PCR test detects genetic mutations that are treatable with specific therapies. At the pre-PCR lab, the lab technician performs the macro dissection, scraping off the excess paraffin and healthy tissue, leaving behind the tumor tissue. Then the slides are submerged in 6 different baths for 2 minutes each, removing the paraffin from the tumor area. After drying, the remaining tumor tissue is scraped off into a tube containing lysis buffer. This tube is heated for 1 hour at 60 degrees Celsius and another hour at 90 degrees Celsius, breaking open the cell membranes, liberating the needed DNA. Now the DNA is ready to be purified and extracted. In the next PCR lab, the technician prepares a mix of different reagents, a so-called master mix. This master mix is added to the DNA and hermetically sealed. At last, we've reached the final phase, in yet another lab, where the actual PCR is performed. It will take an additional 2 hours before the PCR results are available and can be reported to the pathologist. The total time for a BRAF mutation test, from biopsy to result, usually takes up to 2 weeks, depending on the presence of a dedicated in-house molecular lab. Due to this delay, the oncologist can't start the most appropriate therapy immediately, and the patients need to wait before they can take up their fight with cancer.
So, this is how it's happening today. And if you are fortunate to be relatively close by to some of these top centers where this type of techniques is available, so we can do these tests. But many, many parts in the world don't have access to it. And also here, the patient is waiting until those results become available. So, what if we could all change that? What if we could improve molecular diagnostic? Even today, in the Western world, more than 50% of the patients don't have access to that molecular diagnostics. And the reason is often logistics. The laboratory where the tumor samples are received and where the confirmation of the cancer and the staging has occurred often has to send that sample to somewhere else. Traffic jams, and where those samples arrive, often they have to wait until they have enough samples because the infrastructure, the rooms, the equipment requires that many samples need to be tested simultaneously. So, one of the reasons that we've chosen also oncology, and I'll come back to other areas in a moment, is that we want to improve that process. We want to democratize, we want to improve access to molecular diagnostics, and we want to do something about the fact that that whole process of shipping and registrations and lots of manual processes can be optimized. So, my dear friends, this is the moment. What if we could really improve that? What if we could improve and push the frontier in medicine? So after many, many years, we're ready. This is the moment. From a universe very far away, I present to you our two men in black. So, aliens, show the world what so many people have been working on for such a long time. I give you Idylla. This is it. This is Idylla, one of the world, if not the world's most integrated molecular diagnostic system. So if I can get the slide back, I'm going to walk you a little bit through what Idylla is and what Idylla can do. So Idylla, as I said, is one of the most advanced, fully integrated molecular diagnostic systems. Bart, you did a great job explaining that. And I'm going to help you a little bit further. You're going to see here the different parts. There's a console which communicates with the outside world, with the hospitals, with governments in the future, with pharmaceutical companies. You're going to see the role of that console in a moment. That's the communication device. You'll see that action in a few moments. The heart of it is a really laboratory in a box. It's that tiny little white brick that you see there in front, which you see here on the slide, that is doing all the work. It contains all the necessary reagents, all the chemicals, to go from a clinical sample to result. And the DVG drive, the driver unit, is that instrument you see there. So what does Idylla do? Idylla has been the result of a massive amount of engineering work to build the world's most advanced sample prep technology. We can literally take any human sample type into this cartridge. Whether that human sample type is liquid, like blood or plasma or urine, down to very messy samples, slimy materials coming from the lungs, stool samples, down to even materials like you see here, which is a tiny little shaving of one of those paraffin blocks that you saw earlier in the movie. It's fully automated. There is no pipetting anymore, there's no other tubes, there's no requirement to go to a refrigerator. Everything that is needed to do the analysis, to break up the cancer cells, to take out the genetic material, to purify it, to go with super high precision among billions of DNA building blocks to really go and find out what that mutation is. It doesn't require that you have to batch all the samples. You don't have to wait until you have sufficient samples to run the test. No, when the sample is presented, when that patient is waiting for information, the system can be operated immediately. It provides an unprecedented speed. Some of the tests can go as fast as 30 minutes. The cancer test that you just saw takes about 90 minutes. It's not just for, sorry, just not, I don't know what, whether we can lower a little bit the mic, thanks. It's not just for one test. Actually, on one single sample, in standard mode, we can look at 30 different genetic changes simultaneously. And I can tell you, a number of the people in this room are working on some spectacular assays in which we're going to break massively to that, or very significantly to that border. So guys, the pressure is on. So what are we bringing today on the market? For what have we achieved CE marking? We have achieved CE marking for this platform, for the instrument, the console, and we bring today the first test in cancer. It's a test for metastatic melanoma, so melanoma, skin cancer that is spread through the body, and where the objective of this test in 90 minutes is to determine what really the genetic changes is in that particular tumor. And why is that important? Because if you know that, the physician can prescribe one of those newer generations of anti-cancer drugs, which are not as specific anymore. They're really designed to go specifically to the problem. And that's what we're bringing first. We're going to bring many, many more assays afterwards. So what does it all mean for everybody involved? Let's start first with the patient. I am sure that everybody in this room must have now a face of somebody that has cancer. Don't tell somebody that time doesn't matter. If you are in that situation, your world falls apart. You have only 3 important things you want to know. What is wrong with me? What are they going to do with me? And how fast can they do something about my condition? That is what it means for cancer patients. It also means that for the people who have become experts for many decades now, in taking those biopsies and confirming that it is cancer and looking at the stage of the cancer, we provide those people to use their same infrastructure. They don't necessarily have to send it out to some specialist centers and then wait for the data. They can now do that directly there with their team and help their oncology clinicians, their colleagues, to provide, together with the information of the scans and maybe some other information, a package that allows the oncologist to take the best course of action for that patient. These tests and many other tests will bring molecular diagnostics closer to where patients and physicians are meeting. First in hospitals, where already lots of tests are available, but unfortunately the vast majority of hospitals in the Western world, forget even the rest of the world, still today, because of financial, organizational, talent reasons, can't provide those molecular diagnostics to their patients. That's what we and our collaborators hopefully want to change. And finally, it is very important that when we look at innovation, we innovate for sustainability, for progress. Wouldn't it be great if technologies like these can be further optimized, that together with our clinical colleagues, we could work on ideas where the patient doesn't go to a doctor when something is wrong, and when the doctor often has to say, it's a pity that we couldn't interfere earlier because the chances of responding would be much higher. Maybe we could even go to a cure. So the future is to go and interact with diseases much earlier, be more preventive, and very, very important, make healthcare more sustainable. So, this is the end of a journey, but the beginning of another one. And together with partners like Janssen Pharmaceutica, Abbott, clinical centers, VIB, university hospitals here, and the Anderson, many parts in the world, and we're traveling a lot these days, we are going to develop a whole library of what we call diagnostic apps in many, many areas, and you're going to hear more about that in the future. I was very moved by all the respect that you have shown to me. And I thank you for showing that respect. It really means something to me. But I want you and everybody else know the only reason why I can stand here and talk about these so-called successes is because I have people like you. Thank you very much. Hilde. One more thing. You may have wondered why we've shown the launch of Apollo 11. Some of you will say, well, we have heard that the previous project name of this program was Apollo. And Erik Vossenaar, who's here in the room, at some point I remember coined that name because it was a staged project and so on. So that would have been a good reason. But the reason why I wanted this movie in is the following. I was 9 years old when I saw Neil Armstrong and Buzz Aldrin landing on the moon. 9 years. And I will never forget that moment. And I know that many people of my generation were inspired by what they saw there. We're living in a world where no minute goes by that we're telling about crises, wars, terrorism. I hear a lot in society about problems and who is to blame. But what I think, and this is why I make an appeal to new politicians, to entrepreneurs, to academic people, but quite frankly to everybody in our society. Start dreaming again. Aim high. Aim really high, because along the way, on carrying out your dream, you'll have to be ready for some compromises. But shoot for the moon. And don't worry, because if you miss, you'll end up among the stars, where we ultimately belong anyway. So thank you very much.
Thank you, Rudi. There's nothing, really nothing we can add to that. I just want to express on behalf of the entire team our gratitude that we can be part of this fantastic adventure and that we can be part of the Biocartis family. Thank you.
Thank you. I'm sure you're not going to believe when I said that the last 7 years I haven't had one drop of alcohol, but I can tell you, this is a moment, well, together with all of you, I'll have a drink. Thank you very much.
So this is one of the attempts to make it up with Mr. Somers. He has volunteered to be a donor of some of his DNA, no worries. We'll do a very simple test, not sensitive. We will not measure his stress levels now. So what we will do, we will show you how easy and how simple it is to do a test in a non-lab environment. And we will use the factor 2, factor 5 test, which is essentially an indication of an individual's predisposition to thrombosis, which is blood clotting in a blood vessel. So it's an aid for the doctor in prescribing drugs and in minimizing the risk for thrombosis. That's what we will measure. Bart, if you want to come a little bit closer. So, David, one of our friendly, he's not dangerous, one of our friendly colleagues, David, he will give you a cotton swab. So he will give you a cotton swab, and you have to scrub a few cells from inside your cheek, and then we'll find DNA of interest to us. Thank you very much.
Applause. So David. So this is David, also known internally as Scotty. So when the warp drive goes down, he's the man who gets our warp drive up. So David, don't go too fast so that the audience can see what's going to happen. So David already logged on to make sure that the right person operates this. So he's now going to show you how really easy it is. This is a cotton swab. So the first thing that David is going to do is make sure that the proper sample code is typed in. Why is that important? Because we ultimately want that when this result is communicated to the doctors and to the hospital systems, that obviously the right sample is connected with the cartridge. So that is happening right now. The next step that David is going to do is take out the cotton swab again. And in current techniques, you would take other tubes, so that is not needed with the system. So David, if you put it in, maybe can you just move on? Because so you see him making a rotational movement, because inside is actually a little shower. So the shaft will break off, and right now he will remove a protection, just in case the cartridge would, during transfer, be accidentally closed, because the moment he closes this, it's forever closed. Everything which is going to happen in the cartridge is hermetically sealed. So in the meantime, the console has identified an instrument. Now here on stage we only have one, so it's easy, but if you would have 8 units, the system will point out an available slot. And David will now open the cartridge, open the slot, and place the cartridge inside. That's it. So for any human diagnostic test in the future, it will be as easy as this. So adding a blood sample, adding tumor tissue, or adding the result. So this is it. The next step is that, and if the camera could maybe zoom in a little bit on the screen, you would see that the operator now knows in roughly about half an hour the result will be available whether or not, Bart, in your billions and billions of pieces of DNA, there is one typo. So that's what this is able to do. When that is ready, the results will be approved and sent through. So David, thank you very much. Great job. Applause for David.